Hello everyone, welcome to the second part of bar bending schedule. So in previous video we have discussed about the introduction, history and basic points, important points related to BBS, right? In today's video we are going to discuss and find out how can we find the length, cut length or hook length of stirrups. That will be our first thing, and we will do an example, and then the second thing is the bend length, and we will do an example of bend length too. For it, so let's see how we can find the hook length or cut length of stirrups. I hope you guys know what actually is stirrup. This is the stirrup, right? So the hook length is commonly provided for stirrups in beams and ties in the columns. In columns, this is called tie, and in beams, this is called stirrup. In general, hooks are added at the two ends of the rebar in stirrups or ties. We provide hooks at the end of the stirrups or ties, right? These are the hooks. This is the first and this is the second. There are two hooks. We usually provide them at the end of the stirrup in the beam or tie in the column. So we are going to find out the length of this hook. So the hook length is 9D. D is the diameter of the bar. So below image makes you clear why the hook length is 9D. This image will make the things clear why the hook length is 9D. So as you can see that this image has been divided into 4 points, 4 different points. This length from here to here is 4D. This length is also 4D. And then this length from point 2 to point 3 is 1D. So let's see what will be the total length of the hook. To find the total length of the hook, we need to add point 1 to 2, 2 to 3, and 3 to 4, right? We need to add these three distances. So from 1 to D is 4D, and 2 to D, 2 to point 3 is D, and point 3 to 4 is 4D. So we need to sum 4D, then D, and then 4D. That will be 9D. So the hook length for stirrups is always 9D. D is the diameter of the bar. So from above figure, length of hook is equal to curved portion plus 4D, which is equal to, this is the curved portion, right? From point 1 to point 3. This is the curved portion. We need to add this curved portion with the 4D. That will give us 9D. So the hook length is 9D. So I hope it is clear that why we actually took the hook length as 9D. To make it more clear, let's consider an example. For clear understanding, look at the below image for calculation of the total length of the stirrup with two hooks at end. This is a stirrup with two hooks at the end, right? This will be the whole length of the stirrup, and this is the length of two hooks. So what will be the total cut length of this stirrup? The total cut length of the stirrup will be length of the stirrup plus length of these two hooks, right? So the total cutting length of stirrup or tie is equal to total length of bar, which is this one, total length of bar starting from this point and reaching again to this point. This is the total length of the hook or tie, and we need to sum this with two hooks. We are multiplying 2 because there are two hooks. One is this and second is this. There are two hooks. We need to multiply hook length with 2. So when we simplify it, total length of the bar is L plus this 2, and hook length is, as we already know, that the hook length of stirrup or tie is 90. So when further calculation is done, we will get L plus 18D will be the total cut length of this stirrup or tie bar. Got it? The second is bend length. Actually, bend length, there are two types of bend length. First is bend length calculation in crank bars. This is crank bar. We need to find the bend length for the crank bar. And the second case is bend length calculation when bars are bent at corners, like in this stirrup. The bar is being bent at 1, 2, and 3 corners, right? At this corner there are two hooks, and remaining 4 corners are bent at 90-degree angle. So there are two types of bend lengths. The first is the crank bar, bend length calculation in crank bar. As we know that as shear stress is maximum at support in slab, to resist these stresses we usually crank the bars at the end of the support in the slab. So this figure depicts the bent up bar in the slab. To calculate the bend length, the below procedure is followed. This procedure is followed to find out the bend length. So actually it depends upon the angle on which the bar has been bent. If it is bent on 30 degrees, then the additional length will be 0.27 into dia. Sorry, this is important point. This D is not dia of the bar. This is this depth. In the next slide, I will let you know what actually D is. D is the depth. It's not dia of the bar, right? So when angle is 45 degrees, the additional length will be 0.42 dia depth. When angle is 60 degree, when the bent angle is 60 degree, the additional length will be 0.58 into depth. When angle is 90 degree, the additional length will be 1 into depth. When angle is 135 degrees, the additional length will be 2.42 into depth. So the additional length is added to the total length of the bar if the bar are cranked at a certain angle. Got it? So these are formulas. We need to remind these formulas whenever we are doing the bar bending schedule. Let's consider an example. This is a crank bar of a slab. This is the total thickness of the slab, right? So from here you can understand what actually D is. To find out the D, what we need to do? We need to subtract total depth of the slab minus cover at upper side minus cover at the bottom of the slab. We will get D, which is the depth. Got it? Here you can find it. D is equal to depth of the slab, total depth of the slab minus top cover minus bottom cover. Then you will get this depth. So this is D. So what will be the length of this crank bar? As you can see that there are two extra bars of length L by 4. Extra bar at the left side and one extra bar at the right side. Both have the length which is equal to L by 4. So when it comes to find out the total length of this crank bar, we need to sum up all these lengths. The first is L. This is the length from this center to this center. L plus 0.42D. 0.42D. This is the additional length. Got it? And why we are considering 0.42D, as we have discussed in the previous slide, that if the angle is 45 degrees, we need to take 0.42D as the additional length, right? So in this example, the angle given is 45 degrees, right? So that is the reason we are considering the additional length as 0.45d at this side and 0.45d at this side, because the bar is cranked at both sides, left and right. So L plus 0.42d and then again 0.42d, because there are two additional lengths. We need to add both lengths of the bar, and then we need to sum the length of the extra bars on the both sides, L by 4 this side and L by 4 this side. So when you will add up all these lengths, you will get the total length of the crank bar, which will be 1.5 L plus 0.84d, and d is the depth of what? The depth. We will get this depth by subtracting the depth of slab minus top cover minus bottom cover. You can see this depth, which is represented by blue color in this figure. So the simplified formula to find out the length of the crank bar is 1.5 L plus 0.84d, right? And the second type of bend length is the bend length calculation when bars are bent at corners. As you can see in this example, the stirrup is bent at all four corners, right? So when the bar is bent at 45 degrees at the corners, we have to consider the additional length as 1d. If the bar is bent at 90 degrees, we need to add the additional length 2d. If it is bent at 135, we need to consider 3d. If you consider this image, you can see that the bar has been bent at 1, 2, and 3 corners, these 3 corners at 90-degree bend, right? So for these 3 corners, we need to consider 2d as the additional length. And this corner, there are 2 hooks, and the bar is being bent at 135 degrees. Got it? So in this corner for hooks, we will consider 3d as the additional length. So what is going to be the total bend length? From figure, there are 3 bends which are bent at angle 90, 1, 2, and 3. These 3 bends are bent at angle 90, and 2 bends are bent at 135 degrees centigrade. Degrees, sorry. So this bend is, these 2 bends of hook are at 135 degree. So the total bend length will be equal to 3 multiplied by 90 bend length. These 3 corners, 3 multiplied by 90 bend length. What is the bend length of 90 degree? That is 2d. We have replaced it with 2d, and then plus 2 multiplied by 3d. 2 means there are 2 hooks which have been bent at 135 degree, and then we will multiply it with 3d. Why we are multiplying it with 3d? Because it is bent at 135 degrees. If it is bent at 135 degrees, we need to consider 3d as the 3 into diameter of the bar as the additional length. So when you simplify it, you will get 12d. Got it? 12 into diameter of the bar. And in this example, we have given that the diameter of the bar is 8 mm. So we will replace this d with 8, and we will get the answer 96 mm. This is the total bend length for this stirrup. Got it? So these are the important points we need to consider. The first is the hook length or cut length of the stirrup. For that, the formula is 9d, and for crank bars, the total length of the bar will be 1.5 L plus 0.84d. And for the bend length, when the bars are bent at corners, then it will be 12d. Got it? So these are 3 important formulas we need to keep in mind. So we will use these formulas in the coming videos to solve different problems. So till then, goodbye. See you guys in next video.